Hello and welcome to Console Cowboys. So we're going to finish off section 1 of the Python Web3 hacking course, looking at the network side of things since we've covered all of the contract stuff. So we'll be looking at blocks, transactions, pending transactions, revisiting things like 4-byte values and how to utilize them within this part of the course, as well as filtering on various things. So to get started, load up your template on your screen like we have right here, which just makes your connection to the blockchain. Run it, make sure you get a connected equals true. Once you do, you should be good to go to follow along. And again, most of the stuff that we're using in here comes right out of the documentation. So if you look at the Web3 documentation, you're going to see things like, block equals Web3 eth.getBlock. So look through the documentation if you're looking for other things to try out once you're done watching this video. So let's hop right into it. Let's start out by just grabbing this line from the documentation, and we'll start out just printing out the block. So we'll say, hey, let's use the getBlock function, and we're going to grab the latest block. These blocks come out every 15 seconds or so on the Ethereum blockchain. We're going to put it into a block variable that we can print out or sift through. So we'll say print block. I want to grab everything that was in that block. And then let's put this out to an output file. So that way we can, search it if we want and also scroll through it easier than just the terminal. So I'm going to go in here and we're going to open up our file here. And what we'll see here is a bunch of key value pairs. So we have our transactions, and then we have a list of all of our transaction hashes. We could call these and take a look at what's inside these transactions, loop through them, and, just spit out all the information from all the transactions if you want. And what else do we have up here? We have the size of the block. And again, notice these are key value pairs because it's value, value, and then there's a comma in between. So this is a Python dictionary. You'll also notice here's the block number. And then we have stuff like our gas limit, gas used, and a bunch of other various values. We have the miner that put this block up. So that's how you get all the information about whatever the current block is using the latest. Now, I said that these were key value pairs, a Python dictionary, which means we can call each one of these individually instead of printing it all out. So let's do that right now. We'll hop right back into our code, and instead of just saying we want the whole block, let's just pull out our number. So this will grab just our block number with that. The key is the number, and it'll spit out whatever the value is from that dictionary. So let's do that. And we don't need this output.text because we're only printing a single value onto the screen. And here is our block value right here. This would be whatever the current block is because we just ran it again. So this should be a higher block than we just looked at. And next up, let's print out the number of transactions within the current block. So we can do that pretty easy too. All we need is the block number, which we just got right here, but we can grab this in real time here by just saying web3.eth.get_block_transaction_count. I know it's a big long one there. And then we're just going to put the block number within there. Since we're getting the block number right back here, that should work out nicely. So let's do this again, and this should just give us the count of transactions within the current block. And it looks like there's 115 transactions in the current block. So we can also look up a specific transaction as well with eth get transaction, and then using the transaction hash. So let's go back to our output here. We can grab any of these transaction hashes. Let's just grab this one. And I'll copy that, and we'll hop back in here, and let's say we'll do a print web3.eth.get transaction. And then what we're going to do is just paste in that hash right here. And that should give us what we need. Let's print that out. Within this, we have all of our typical stuff that we saw within transactions when we were sending them and making manual transactions. We have our gas price, we have our gas, we have our input, which could have some kind of 4-byte value depending on what it's interacting with. We also have our to value, and we have our from value up here. So you're familiar with all of this, and this is how to get those transactions and do a little bit of network programming. We can also get all of our transactions directly by calling them and just printing out that list. So let's do that now. We'll say print. We want to grab our block again, and we're going to say transactions. And if we print that out, we're just going to get a long list of transactions. So let's take a look at that. So here is our list of transactions. So let's loop through there, and then we can print out all of the transactions. So in order to do that, here's what we're going to do. We're going to get rid of this print statement here. We don't need that. And we're going to say for transaction in, and we want to do it within this block transactions list. Let's loop through here and print out each transaction. And of course, this has to be within parentheses for Python 3. So let's take a look at that now. This should give us a list of transactions. And we get back a weird format. And we've seen this before when we were dealing with other things. So we know that we have to do this in a 2-hex function. So let's do a web3.2hex. And this should take care of this issue. So we get back the proper transaction hash format. So let's give this a try. So a lot of this stuff is pretty easy to do. It's just like, what kind of data are we getting back and how do we deal with it? So now we have a familiar format, right? This is the same format that we put in here. So we should be able to call this same exact function within here now. So if I copy this and we say, for each one of these, we just want to run our web3 ETH get transaction, convert that to hex and grab that transaction. So let's do that now. And what this should do is it should take each one of these values and just say get transaction and print out the transaction hash values, which should be a lot of output. So how about we just put this to a transactions.txt file. That way we can just look through there really quick. Now this is probably going to take a minute to run because it's going to grab every single transaction and print it out from that block. And there's could be 100, 200 transactions within that block. So here we go, that just finished. Let's take a look at our transactions.txt. Within here, we have all of our transactions from the block. So there's a whole bunch of data in here. So what's in here? Well, we have, again, our block number. And then we have our chain ID of 01 because we're on the Ethereum mainnet. We have our from, we have our hash, and within our hex bytes, because it's that 2-hex format we have to use to convert it, we have our hash for this transaction that we can look up on the Ethereum mainnet, as well as we have our input, which could have something we want to filter out on. So let's take a look at how to make sense of all of this data, because obviously looking through all of this stuff manually will be painful. So let's look at, we know what bytecode is. We know what 4-byte values are. How can we utilize that knowledge and the reverse engineering we did before in order to do some network programming to filter out some of this stuff? And, maybe we're trying to do some kind of IDS type of thing where we're looking for certain kind of transactions. Maybe we're looking to monitor certain from and to addresses. Really depends on what you're trying to do. But let's take a look at a couple of use cases here. So let's load up Etherscan. And what we're going to do is take a look at the different transactions there are. So if we look through here, we have things like approve, transfer, deposit, transfer. And these values are associated with those 4-byte values that we saw when we were searching through the bytecode. Now, if I scroll down and we say click show more, we'll see that that's associated within the input data to an approved function, and it has this method ID. But what if we didn't know this method ID because we weren't searching Etherscan for this? We're just looking for something very specific when we're monitoring the blockchain. Maybe we're trying to hack a game and we're looking for a call to a transaction in the mempool and we're going to front run that, something of that nature. How would we figure this out? Well, again, we need to know what that function is, and we can figure out that value ourselves. Then we can look it up and check it out. On our keycac hasher, and we've seen this before, we're just going to paste in our function here, and we're going to get rid of that name there and get rid of the spaces. And then we're going to get rid of this and back it up to here. And what you'll see is 095EA7B3, which matches the function ID right here. So that is what we could search for on the blockchain. Let's say we were, just monitoring a specific contract. So we're monitoring on a to address, and then we're monitoring on a specific function getting called. We could do that with this method ID value. So we'll now hop back into our code and only print out a transaction if it has an approved function in it, just as a proof of concept that this is working. We have most of what we need already. So right here, we're saying within our block of transactions, let's use this transaction variable. And right here, we're just printing out this transaction. Instead, let's put this to a variable. We'll just call it values. This is the value of our transaction. And what are we going to do with that value? Well, I'm going to get rid of this here so it's out of our way. And what we need to do is say if, and we need our value that we're searching for here is in value, and we're going to look within that input field within our transactions. If you remember in here, we have our input, so we're just going to search in there for our value. And if our input value exists of this approved function, well, we want to print it out. So we'll say print, we'll say web3 to hex, and we want to grab the value again, and we're going to just print out the hash value so we can look it up on Etherscan and validate it without having to look through and parse out things from the input, because that's what this is doing for us. We just want to look at it in a pretty way. So here's what's happening here. We're going to say, okay, let's grab all the transactions in this block. We're going to put it to this transaction value. And then we're going to say, okay, let's grab the transaction hash and let's look it up with get transaction and put it into a value. Now within that whole transactions value, let's search within the input field for an approved function. If this approved function exists, we want to grab the hash of the transaction, convert it to hex. We're going to look it up on Etherscan and we're going to validate that we were able to parse out approved functions. So let's do that now. And then what we should see is some transaction hashes coming back. And each of these transaction hashes should only be approved functions within the input field. So I'm just going to grab, say, the first transaction here. And this is off the latest block. And we'll go to Etherscan, and I'll paste this transaction in here. And let's see what we got. So if I go down into here, we should have an approved function, and we do. So let's check another one of them. Let's just grab a random one in here. And we should also have an approved function because we're looking for only things with those 4-byte values. That way we can parse out what we're looking for when we're doing our network programming. So let's do this again. And indeed we do. We have the approved function. We've actually covered a ton of information in this video so far, so hopefully you learned something. If you did, hit the like button below and follow me on Twitter from the link in the description. Now I'll just do a quick recap, and then in the next video, we're going to take a look at some more asynchronous programming, but this time with network programming instead of the contract programming and pending transactions and filtering some stuff there for various attack stuff. Now to recap, we were able to grab our blocks, we were able to grab our transactions, we were able to then create our own keycache hashes of functions and filter out for those with our if statement on here to look for specific things happening on the blockchain. So with this, we can make a crude intrusion detection system, monitoring to addresses, from addresses, certain functions that are happening on those addresses, or whatever you can think of on the project that you're working on. So hopefully all of this stuff is useful for you, or hopefully it's just enlightening to show you, all of the things that are going on if you're not very familiar with Web3 and how the blockchain is functioning. We're able to dive in here and do a little bit of nitty gritty and do this all for free with our Infura, network connection, because we're not making transactions that cost anything here. We're just monitoring what's going on. And I hope you learned a ton. I'll catch you in the next video.